about celebrating what I think is a glimpse to the future of India.
Often we believe algorithm has to begin from the hardware.
This is something unique. This is something I haven't seen in these 22 years that I've been applying the technology.
This product can be utilized for application use cases beyond just industrial robotics.
Thank you so much for respecting us and being here and spending this time. One of the key things before this panel discussion that I wanted to actually bring about is when we witnessed this crowd, right? So we didn't grow out of just the two people and then build all of this. Everybody here has played some role or the other for us to be standing here and then addressing you all back here. And ecosystem matters more. We are not just 35-member team. I'm answerable to this larger crowd that actually sits here. And somebody or the other has invested back in us in so many different fashion, in so many different matters, and we have multiple different stakeholders. An organization cannot be built, especially a hardware-heavy organization in this case, right, without having the participation from the whole of the ecosystem, right? And some veterans in each of the stakeholder partnership that we actually have today will join us in this panel discussion, and a very interesting crowd. One who has actually spent a good amount of, almost all of them have actually spent a good two decades in this industry, right? So we have a very good mix. Mr. Ajay Gopalaswamy, who has been at the crux of building an robotics integration business in India, and it's a very difficult business. And he has been very successful, one of the very few successful companies which have managed to do that over almost 15 years now. And he began his career probably from ABB and Fanuc in his past. And I would like to invite him to the stage. A round of applause to Mr. Ajay Gopalaswamy. Thank you so much for being here. Please. I also have Mr. Rama, who has been witnessing this whole evolution of how the tech space have come about in India and at close quarters. And he has been associated with the capital market for a very long time now. And he has been part of Venture East initially, and he is currently being a director of the venture capital arm of Qualcomm. Welcome, Rama. Pleasure to have you here. We also have another veteran who has witnessed the whole growth of machine vision from its scratch, right? It's a very nuanced field. People are not well exposed to that idea of machine vision. We all might have heard of computer vision, but there's a very unique perspective from which machine vision has begun, and he has been at the center of all the revolution of AI and all the technologies that have come about in machine vision. He has spent more than close to 3 decades, if I'm right, in this whole industry, and 4 now. So yeah, wow. So that's a lot of time. Let me invite Sven. We have the pleasure of having him today to share his perspectives. Thank you so much. Please be you see. So interesting things to come about. I would like to start with Ajay first. And we knew Ajay from a very long time, even when we were not even have initiated our initial organization much before 2018. Must be around more than 5 years, I guess. He has always been inviting young entrepreneurs like us with open arms, and he has built this industry from scratch. So one of the first interesting things that I have come across when I entered your facility, right, was a very interesting quote that you've actually written there, right? I would like you actually to bring about the quote, and I wanted to understand what is the perspective behind that, and how what was driving force for you to think about such an articulation.
Thanks for the introduction, and It's a pleasure to be here and in front of such an august audience. Um, it was a very inspiring speech from Sir, and we are really pleased to partner with CynLr. So it was, I think the quote you're referring to is that
The sweetness of the low cost is soon overcome by the sourness of poor quality.
yeah.
Right.
So the point was at that time, we were kind of, we were always coming up against price barriers, price competition. But as we have matured as a company, the code that you saw was probably, it's been there for 10 years. But over a period of time, as we matured as a company, we kind of understand why customers do want low price. Of course, quality is a given. Okay, that is, there's no compromise on that. But at the same time, our customers are also in a very competitive environment. So, like all of us, we like to get good products at a good price. So that's what they are looking for. So I have no problem with, our customers demanding both good quality and the cheapest price. I think it's up to us as automation solution providers to convey our value to our customers. And, especially in capital goods and solution providers, automation, no two solutions are exactly the same. Okay, right. There is always a difference in features in terms of productivity, quality, whatever. So it's up to us to convey the value that our product offers to the customers and make them realize, and then customers are ready to pay for it. I don't believe that Indian customers are any different from global customers. Everyone is the same. They demand good quality, good value, and at the best price. So, I would say we need to respect that.
Right. So one evolution that I wanted to again see, right? So there is a famous perception, right, that at every point, every juncture of each of these heavily industrialized countries, when they actually became industrialized, at one point of time, we used to think of China as a poor quality market, right? And but of a lot of volume, right? Japan was preceding that. In fact, probably Korea before that, and then probably Japan even before that, right? So, and it kind of when they mature, there is a focus towards this quality as a factor, right? And in fact, the way the governance was and the way the amount of hardships that 30 years back the market used to face, that Mr. Shirgurkar actually would have actually felt a lot of it, and then yet to make it out of that and then build whatever the organization that they have actually built today, right? So those successes were built on the basis of bringing that value to the customer at an affordable price at every point of time, right? Is there also another perspective about this quality as a market, right? Is it a time that along with the price advantages, does India have to evolve to also bring in the quality at this point so that we can compete with the global market? Or would our value now with the competitive other markets, let's say somebody from China, would also be only at the price at a higher quantity, or it's also the quality thing that we have to compete with the rest of the markets?
Yeah, you're right that, when it was Japan initially and then China later on, the initial products that came out of Japan, China were perceived as low quality, but nobody seemed to mind because they were at a low price. But then we all know that Japan quickly upgraded quality, and now even China has done that. Yeah. And we in India are now entering into where they were right now. But unfortunately for us, we don't have the luxury of saying, I will give cheap price without quality. Now, see, our market is the Indian consumers who are very demanding. They have tasted international quality. They will not settle for anything less. And of course, then when we go out of India, they know what is world class. So, there is no question of trying to sell products which are below world class. So, we don't have that luxury, unfortunately. So we have to do quality, cost together.
Right.
Okay.
How do you think that would come about for a robotics core industry in this case? So you are rooted in the automation and robotics industry, right?
Yeah.
So if that evolution has to come about, so there is a huge success that DiFacto has gone through, right, in trying to bring about, and then also not just catering to India market, but you also have, scaled on outside the India borders, right? So what was there any such insights that you could share that drove that perspective for you?
So yeah, I mean, as I said, Indian customers are as demanding, or I would say probably the most demanding customers, but fortunately they are also very forgiving. Okay, so international customers, American customers, European customers, they are of course demanding, but they are not forgiving. Okay, so they give you a chance once. Indian customers, in our experience, in my experience, has been that they are demanding, they don't compromise, but at the same time they give you a chance. They give you another chance to prove yourself. Yeah. So that's something that we are very grateful for. I mean, we work with companies like Maruti, Tata Motors, Mahindra. They are in a very cutthroat market. Yeah,
that's
and
true.
they can't afford to have mistakes. Yeah. But we have made mistakes, I have to admit it. Our systems have not delivered sometimes. They have broken down at very crucial times, but they've given us chances to improve ourselves. And we are very grateful for that. And, that's helped us build our competence level, and we feel more confident to go out into the global market now.
They gave a growth space for us to evolve into a quality.
Absolutely.
Right. Yeah. So the next question is to Sven, and you have witnessed the whole evolution of machine vision in Europe market as such, right? So one of the key things that I wanted to see or kind of get your perspective is people have a fancy notion of what robotics is and how it might be in how automated many of these lines might be, manufacturing setups might be, right? Can you paint us a picture of how mature is the tech? We also see this in popular, media. Boston Dynamics is everywhere, and we also, face this KUKA playing TT and thousands of claims on the robot bin picking and things that we actually see that the automation has actually happened, and kind of there is a perception that the tech is already there, and probably it's an adoption problem or probably articulation problem that might actually have. But is that the scenario? Is how close it is, or how much of ordeal somebody who's trying to automate robotics goes through typically, right?
I think I would like to start really when I started with robotics. That was like more than 20 years ago, and some of the people here in the room, we all started with the same robotics company out of Sweden. And back then, robots were considered like job killers. When I came to the industry, when I came to factories, I really wouldn't tell where I'm from, because people knew that the company I'm from makes robots, and people were expecting me to replace their labor. In fact, I mean, if you look where I'm from Germany, the German industry wouldn't be at the point where we are, this point in time, without robots. So that perception has completely changed. That from being a job killer, it basically saved the industry from being eroded. Because a lot of the industry we lost them to Japan, we lost them to Korea, we lost them to China, now they're coming back, so that was sort of the long-term cycle. And if you start working with robots, very soon you notice they're great machines, but without perception, they're nothing. It's like a human being, if we are, as humans, lose our eyesight, we need to develop other senses, and that's exactly what you do with a robot. You need to support the robot with a perception of its environment. And that has definitely grown over the years. But to the date, it is a challenge to explain to someone, how does machine vision actually work, Every one of us has witnessed computer vision, Everybody's most likely been X-rayed along his way, So we know nowadays you can apply computer vision to this and help human beings find so-called defects in your in your images.
Yeah.
But when it comes to robotic guides, and this is sort of the king's or queen's discipline that you are applying, it's still pretty complex, because I think a lot of people don't really understand what happens in a human being when it's grasping something. I mean, you can look at a little baby, you know, what little baby does, it uses all kinds of senses it has. It might actually put it in its mouth to taste it, to smell it, to touch it. So you have, at some point, we as humans have prior knowledge. And what you are doing, you don't have anything, you know, you don't even have prior knowledge. You see it for the first time, you look at it, you know, you're the first one actually twinkling with the eyes, and then you are able to grasp it over a very short amount of time. And when I saw it for the first time, I thought, this is something unique. This is something I haven't seen in these 22 years that I've been applying the technology, and that's why I'm here today.
Very nice. Thank you so much. And that's a great perspective that you're actually adding about how the tech has actually evolved beyond. So, Rama, I would like to ask a portion of, you have witnessed a lot of startups come out, and you have been part of their journey, being part of both Venture East and Qualcomm for some time. One thing we kind of often notice, it's also globally true, but also is very much true for India, is that the participation of deep tech coming out of venture capital backed systems is, and even the proportion of the deep tech in itself being supported is kind of very less in the percentages. Is there any specific factor that is guiding it or limiting, and if we have to try to evolve out of it, what do you think could be the way? And you are actually representing Qualcomm, which is kind of a very deep tech organization in itself, right? So, yeah.
Thank you, Gokul, and first of all, congratulations on this great facility and also the journey so far.
Thank you so much.
I remember meeting you 2019, I think, both of you, before the start of the venture, and it just feels
in some cafe somewhere in
here. Exactly, and look at today, right? It's something to celebrate. Congratulations.
Thank you so much.
To your question, I think we as a country are going through an evolution, and as Sir mentioned, there is decades more of evolution to come. Now, to the question of deep tech startups, should there be more or should there be less? Look at the 90s. I think the private entrepreneurship, 90s and prior to that, was mostly in services, in IT services, even in manufacturing services. The decade after, and especially in the last decade or so, there used to be a discussion in fora like this that we are a service economy, and even in software for that example, that we've not been able to create products. Are we a product nation? We are a service nation. And this was a narrative that was there. And today, nobody is talking about, are we a service nation or are we a product nation? We are both. We have created software products, and some of our companies are very successful, not just in India, but globally, with going against the best. And when it comes to deep tech, so that is the next level of complexity and the kind of challenge that is there to deep tech is order of magnitudes more than what it is for a software startup or a software product company. But that said, I think we are seeing crops of companies. I mean, there's a whole bunch of companies that are coming. 2021, if my numbers are right, about 160 companies in deep tech were funded, 2021 in India. I'm awaiting for 22 numbers yet. About $1.35 billion were invested in India.
Wow.
And I know there are investors in this room. I know Sudhir is there. There are definitely investors who are looking at deep tech startups, and our common portfolio, IdeaForge, India's best drone company, and many of you might have seen it, has filed to go public about 2 weeks ago. And we will see how such companies are received by the markets and received by the investors. What happens is often, we tend to follow a particular template which has worked for somebody or somewhere. And there are often people who break that mold, which entrepreneurs are always breaking. But there is also, on the investor side, there are also investors saying, no, I don't want to do that. I will try to bet on a different thesis, which is Vishesh's thesis, which is Specialist thesis, and of course there are many others in this room as well. Now, that has to be proven. There are other investors who are, equally smart.
Right.
The reason why they don't do it is that they're waiting. There are a few who take the first step, and there are others who will take probably the second, third, and it will just evolve.
Right.
So I would say a short, longish answer to your question is that I think patience is very important, more so in deep tech startups, as Sir mentioned.
Patience does cost. So
Yes, but then we will have to create role models in
Definitely.
in venture-backed companies, in private entrepreneurship, in deep tech. The moment entrepreneurs, young companies, and even investors see role models, then we can now take that confidence of saying, okay, we are mature now, we are maturing, and this is the right time to bet more companies.
Right.
So I think we are just starting at that cycle. The next decade we will see more.
Nice. So this brings to another follow-on thought that actually comes into it. So is it also the reason that there is an underrepresentation of manufacturing and hard deep tech oriented people being represented into VC world or the capital market, right? We see a lot of people had their background from the software industry. We see a lot of people have had their background from fintech industry and finance industry for the case. But could that be a key motivating factor for somebody to understand the nuances of value that is hidden in these ideas and probably also foresee the scale upfront? So that's one. And how much of that play should come from an active participation or active representation from the industry in itself, industry's foray into the capital market, right? How could that seep through in? And
so I see two parts here. To the first part, whether the venture capitals themselves or the investors, do they have expertise in manufacturing? I wouldn't think that is probably the reason why it is underrepresented. Okay. That probably is not the reason, because venture capitals, one thing is that they tend to broaden their perspective. That's their job. That's what they're paid to do. So the real reason, I think, is the risk-reward equation. And that is what every finance person deals with. And in fact, every business person also has to consider for any business decision. Right. So what they're looking at is what is the right time to take that risk and to what reward.
Right.
So manufacturing, we have, as entrepreneurs in manufacturing or the industry, what we need to look at is, okay, how are we presenting this risk-reward equation to the investors? And then the investors will jump in, and I'll give you the very recent example, or not so sort of long ago, Tesla's IPO and how Tesla's growth has in the recent years. It just another car company if you look at it, right? Yeah. But no, the excitement that it was created at the first and then sustained, and to what it is today, even despite some of the correction in the market. It is all about how do you present the risk and the reward, and Tesla is valued for whatever it is, significantly better than its peers. But if you look at their numbers, they are showing that the margins are 25%.
They're the
highest gross margin company in automotive. Yeah. Versus the next best is about several points lower, 19% or so.
Almost 3x.
So that is what investors look for, risk reward. The moment industry starts to look at how do I present myself and the risk reward equation, then investors are the first people to jump in. They will jump in where there is the right time for risk reward.
So there is a way of how we project and then bring the value to the in an easy consumable way for them to start making the decisions.
That's right.
Much
and then
quicker.
Capital also is one factor. The second aspect is some of the companies require a lot of capital.
Right.
And for the same capital, they have better...
The kind of outcome that somebody would be able to bring
about. So it is in a company like what you are doing, that some of that risk is taken away. With less capital, you're able to show the kind of impact that a company like this can do. Yeah. So that, again, is a very important consideration.
Factor too, kind of. And the other part of the question where how is the representation of, can the industry in itself representing through a venture arm, like what Qualcomm is doing, would make it easier for those templates to be formed because often they do not know how to judge. They do not know at an early stage when I'm just stepping up with this, and for us even to show a prototype, right? It took us more than a $500,000, right? $700,000 seed, out of which $500,000 goes into the whole infrastructure that you have to build. And there are 1,000 things that we have to depend on. There are more than 400 parts that we bring from across the globe. 90% is outside of the country. And for us to be able to bring all of that and then start showing it, it takes the bare minimum entry capital. And there is this barrier that we have to kind of cross at every point, right? And how would an investor be able to understand, and if it's something that is existing, that's great. But if you are building a tech that is yet to be built, right, how can they kind of, see whether this will, progress, or this is something that it's worthwhile taking that bet into? Some mavericks do, but not everybody would actually have that thesis for them to even do that, right? So
yeah, this is a very important, actually, the question behind the question is, there are many great ideas, right? Entrepreneurs will have
absolutely
several
every day,
ideas.
yeah.
And why does one get picked and one doesn't get? And or looking at from your perspective, what should be a smart strategy to be picked by an investor and to be successful in this? Because pretty much everybody is starting from the same slate at the time of your founding of the company. I think it's important to be guided by customers, I would say. Find a use case, find a market, find a problem that a customer is saying, look, this is hard, I'm finding it a challenge, and perhaps they will help you with, specifications or designs or even data in today's world. Some of the data which is required to do AI is not with the startup, and perhaps if there is a willing customer who is going to invest their not just time but also some kind of emotion behind that this could become a game changer for themselves and perhaps the industry, that is very important. So if we try to build solutions in an isolated environment and then try to go out to market and see, does anyone want it? Often that doesn't seem to have worked. What you get out of this model is the confidence that there's an customer who's validating the specs.
So that becomes the validation.
That becomes the validation for the investor as well. And sometimes these companies, your customer, they also invest.
Right.
Small amounts, whether it is in whatever fashion, but they invest. Again, that shows confidence to the investor. So that's how you sort of kind of chipping away
the chicken and egg
problem.
This kind of is getting broken in the.
So if you were to do it this way, and then find, not every customer will be perhaps willing, but there perhaps is one customer, you still have to find them and get them to agree to you.
Absolutely. Sven, I just wanted to pick it from here to another thread.
Yeah.
So we often hear the statement, the world is made in China, right? And there is another statement that comes that the China is built in Germany, that all the machinery that they have built and the tech that they use on the foundations of which the manufacturing, the behemoth of the manufacturing that the China has become, has been sourced predominantly from Germany, and probably
to some extent,
5 years back, it used to be the statement, right? The Chinese go to Europe and then come back shopping companies, right? So,
true. Yeah, which they did.
How did EU become that that savvy with deep tech in that case, right? So we kind of keep talking about the entry barriers that is there, and the level of things that you have to cross, and the amount of things that you have to get the access for us to start building. Some of you as consistently have managed to to continuously keep giving industry applicable tech in this case. So what do you think is something that we can learn from, or the factors that is enabling them to be?
I think, I don't know why you became an engineer. The reason why I became an engineer, because I was curious, and I remain to be curious. And I think this is what still drives me. And I think this is, like anywhere in the world, we're curious people. And that's what drives us. And as your keynote speaker mentioned at the very beginning, we all make failures, and we learn through failures. And machine vision is one of the disciplines that helps us not making these mistakes. Because no matter what degree of education you have, we're destined to fail because we learn. You know, and if you want to make a quality product, you know, you can apply machine vision for simple decisions that pass and fail. This has been used for more than 20 years, and this is why companies like Cognex or Keyence from the US or Japan have been incredibly successful, because they've taken all these issues away from us, you know. Cognex started in the semiconductor industry, high-speed applications, nothing made for human beings. Human beings are perceived as a contamination. That's the environment where you use that kind of technology. And what's happening now is that this technology is moving out of these areas, it's becoming more widely available, and it's constantly evolving. I mean, imagine, when I started applying machine vision, that was in 2002, we had to use a single industrial perceive from Siemens, incredibly expensive for a single camera. We had frame grabbers, you know, and I told you, I mean, it was a surface inspection task for a car vendor in Germany, and we had 61 PCs and 61 cameras, and we had to build the mechanics ourselves and everything, plus the software. You know, that was a major risk that we took and that Volkswagen took back then, but we managed, you know, and that's how we learned the curve. Today, you have a mobile phone, and all this is integrated into something which has the size of a pack of cigarettes. So this is like 20 years down the line. Right. So using your technology means you have to be ahead of the game. You have to be constantly curious, and you have to develop. And naturally, developments take time, therefore they take money. But they shouldn't be happening in an ivory tower. And what I see here is you're applying your technology. Right. The challenge will now be, who are the right customers for you guys to make it big, because it has a huge potential what you're doing.
Absolutely, absolutely. In fact, drawing a thread from this, it's a question for both Ajay and Sven, as you can actually bring your perspectives. So manufacturing is typically, 70 years before, it was a great phenomenon that actually come about, that you could bring in an assembly line concept for everything that we actually could produce and then manufacture, from which even the way programming has actually have evolved from that, right? So the way of the schema of the way that has been put together, right? Yet manufacturing is often seen as a cost center, and in fact, I'm drawing the line from your earlier point, right, where customers are also restricted in a way. When you are a cost center, the motivation is always towards reducing the expenses in certain way or the other, and they sometimes do look at machines as a cost replacement for whatever that they're incurring, right? Is there a way that customers can, manufacturing industry can start looking at their infrastructure actually as the product and as an earning center, than just looking at only as a cost center? If that is about, what kind of machinery transformation that should have happened so that they could can start looking at it now more utilitarian and as an earning center. Of course, we have manufacturing service companies which do look at their assembly lines or product lines or the manufacturing lines as their the earning center. But can this percolate into the general assembly? Can it percolate into the typical manufacturing per se, that the manufacturing infrastructure becomes the earning center?
The question, I think it's quite easy to answer. I mean, I don't know what it's like in India. I'm really not an expert on the Indian labor market, but what we see is we have labor shortages everywhere, you know, and as soon as someone's getting paid a better loan somewhere across the road, they might be changing their job if they're looking in like simple logistics. And a lot of the tasks that robots are performing are logistic tasks. Placing, putting, placing. If you put them like on mobile robots, same task. Someone's been previously driving like a forklift or anything else. Now you place it with an AGV or an AMR. So that is really the driving force behind it. But areas, for example, like I think we all remember the pandemic, how badly hit the pandemic everybody. Yeah. The companies that were boosting in this were e-commerce companies, you know. They were suddenly the companies selling because everybody wanted home deliveries. This boosted the market, boosted robotics, boosted machine vision. If you look at the startup scene in the US, how much money they've collected in Series A or Series B fundings, that's obscene. You know, we don't see anything like that happening in Europe. That is really, or take the pharmaceutical, the life science industry. If you imagine a standard quality laboratory in a pharmaceutical or chemical company, and I mean, you are working with ceramics, I have a background in ceramics, that's what I studied, and there, a human being is also considered a contamination. So you have very valuable expensive analysis technology sitting in a laboratory. Do you think these people are working 3 shifts, 7 days a week? No, they don't.
Right.
So if you apply your technologies in an environment where you have really well-educated people in a laboratory, people with a master's degree, even some of them having a PhD, what do? They collect samples, carry them from A to B. You know, these
lot
guys,
of physical
and these women, and they have a huge brain capacity. So you're sacrificing brain capacity on repetitive, dull tasks. And so I think there is so much potential for the application of this. Laboratory automation is for sure one of the next things that's going to go big, and that's going to go big anywhere because you want to use the technology you've got sitting there on a regular basis, not just one shift. So plenty of room for improvement.
So my perspective on your question, was your question is, can manufacturing become a profit center?
Profit center, earning center.
An earning center rather than a cost center. Yeah, I mean, it surely can if we, if we bring in innovation. If you do the same thing over and over again, then there is very little scope for that to happen. And innovation comes through technologies like robotics, like your vision system, vision innovations that come in. So all that you have shown, these wonderful technologies, once they start entering the manufacturing space, that's when, new thoughts, new ideas can come in. As Sven said, during the pandemic, there were so many, or even before the pandemic, the new thing that has come in is the variety of parts, or the variety of production.
Right.
It's not now a mass-produced single model running for months or years together.
Right.
It's now a mixed batch of parts, quick reconfiguration. So you need to have flexible lines, lot of intelligence that, like you guys are building. So those are the kind of things that will help manufacturing become, profitable and, and address the customer needs very rapidly, very agile, in a very agile way.
Right.
So that's my perspective.
So somewhere there is a limitation today in the technology that there is a rigidity in certain kind of infrastructure that they hold, which is holding them back.
See, I mean, robots have been around for a long time.
Yeah.
So a lot of
Probably 40 years now.
Yes,
Yeah.
and then the deployment is accelerating now, especially with the events over the past few years. So there is a huge increase in automation. So there is technologies, and even in low cost, labor cost countries, like supposedly like in India, that's also accelerating. So that there is no limitation of technology. It's a matter of the business case being made to project that you can use manufacturing in such mixed manufacturing scenarios, mixed models, short batch times, single piece flow. So that's where automation can come. Needs to be thought of. Because robots are, the traditional image of robot is you program it once, it keeps doing the same task. It'll do it well, but it'll do it 1,000 times.
Right.
But today you can have a hatchback car coming, you can have a SUV, and then you can have another, like a pickup truck coming next. So it needs to be flexible enough to recognize the model and then select the right program to do that task.
Right.
And I'm just talking about automobile, but there are, we are working with foundry industries in Coimbatore, and they have the same foundry producing about 50 parts coming out in the same day.
Line.
Same line, same day. Because
same day. Wow.
Yeah.
There's a lot of variety that comes out of the
There's
foundry
a huge
system.
variety of parts that are coming out, and they need, they need automation to address that. Right now they have people, and Sven said, you should not use people to do that kind of work. Really, it's inhuman. Actually.
Right.
So you need to find solutions to make that happen.
Right.
There are some, some standard off-the-shelf solutions that are available, but there are a lot of difficult problems that are still to be addressed. And companies like yourself have a huge opportunity to do that.
If I may add to this,
Right.
I think the world that I come from has a lot of examples for manufacturing. So from the fabless semiconductors, if you look at how that industry works, they don't own their manufacturing.
Right.
Qualcomm doesn't own
ARM
it.
is one.
And
yes.
there are, the manufacturing is with another partner, and which requires significant capex and sophistication. That the part I want to stress here is the sophistication of managing a fab is orders of magnitude.
Much
than
higher
what,
than
what one can think of.
Yeah.
So that is specialized, and everybody, all fabless companies just go there and they get their thing done. Now, there's one company which always had its manufacturing in-house, and they prided themselves on that. Intel,
yeah.
right?
Yeah.
And it was to your question, it was a cost center, right? It was, at one point of time, it was an advantage to them.
Right.
And it started to dawn on them that it is a cost center. What did Intel do? What did the recent leadership do? They started Intel Foundry Services, and now they're saying our foundry is also open for other fabless companies, right? Companies who want to use
NVIDIA
it.
can ask.
Right.
Yeah, right.
Now, this in the automotive or in the manufacturing world is not unthinkable, but it has not happened for various reasons.
Right.
You could think of the design or think of the fabless model where the IP is there, the brand is there. You'll have to have some IP, right?
Understood.
Then there is a company which can become this integrated manufacturing plant for many companies. So it is a revenue driver like Foxconn for that business, whereas you keep your IP, you keep your brand, and you keep working on some of the innovation. That's possible, but it's not happened yet.
Okay, right. Brilliant. So it's been a very, very inspiring thoughts and perspectives that you were able to bring about for each of these different problems that we also face. And every time when we kind of look into the industry and start observing these things, so there are some conundrums that we kind of try to break and try to understand what's actually going to happen. And one way that, again, picking from Rama's thread, the last point that I wanted to again understand from is there any possibility that we can foresee? In fact, when I look at the history of semiconductor, right? Around 1960s and 70s, before the invention of 50s, when the transistors happened, and then when we started making the ICs, integrated circuits, which people started noticing that you're just seeing a certain pattern of circuits being reused every time, and they wanted to just make it into an integrated circuit. And they noticed that, and most of that being used for arithmetics and logic, and they made an ALU, and the computer has been born, right, suddenly. Could this kind of an universalization ever happen in manufacturing when it comes to object processing, right? When we think of data, we all have witnessed those pictures where in 70s and 80s, the number of devices that you used to have on your table to process data, right? You used to have a calculator, you used to have a typewriter, you used to have a mobile, so telephones and, the radios and gramophones and whatnot, fax machines and whatnot. All of them now in your phone, right? It's unimaginable that someone could have actually said that in 80s, right? Is there a possibility that we can think of that audacious goal for manufacturing? And if it could be, how can we think about it? What is that flexibility or that universalization that we can actually bring about? It could be anything that comes to your mind. Especially, Ajay, you actually notice that for every one system that you actually build, it is never identical to another station or another solution that you actually give to customers, right? So could this status quo be changed? Could this be transformed such that it becomes easier for the businesses?
I think it absolutely can be done. I mean, there is a standardization. The robots themselves are now
already standardized.
Right. Standardized. So we can also standardize solutions that can happen. And when you, apart from automation, if you just look at what Tesla has done in the EV, they have just radically changed a particular process in their car body manufacturing.
Nice.
So the underbody used to be a lot of sheet metal parts welded together. So these guys said, why should we do that? Let's just cast that
The
whole
whole thing.
single big piece. So they took this giga
Factory, the giga press.
ton, giga press, exactly. So they got their supplier to build a giga press, and they cast this entire car underbody in just one shot.
Right.
And they eliminated a lot of processes by doing that.
Right.
So there is huge scope for rationalizing. We tend to think that things cannot change, but the human history and you brought out the example of the IT and the semiconductor. They have been fantastic in innovating. Manufacturing, especially the traditional manufacturing, has been slower to adapt to these new thought processes.
The thought process specifically more than.
But there are disruptors like Tesla. I'm sure there will be a lot of scope. I saw one of your partners here. He's talking about robot as a service, offering robot as a service. That's a fantastic, thought process.
Right.
So there are, there's still a lot of innovation to be done in standardizing, productizing, bringing things to modularization. We are ourselves working on some of those ideas with some of our customers.
Right.
So that's surely, that's going to happen. Yeah.
Sure.
And quicker deployment. That today when we talk of one automation line, takes months to deploy. There is no reason why
it should take months together for us to come up with
there's a convergence of digital technologies like virtual commissioning. So you commission the machine offline, and when you build it and you assemble it at the customer place, you can get it starting in a few days instead of months together. So those things are happening, but we need to bring it into the mass and make it
in a more standardized manner that we can
standardize and faster to deploy kind of model.
Right.
I think that's a very good example you're making. I mean, what I saw happening, for example, to the machine vision industry in Europe was we always had like a German machine vision association, closely attached to the VDMA, which is for the machine and line builders, a huge organization. They organize the Hanover Fair. Everybody's most likely familiar with this huge industry fair. Yeah. But it really took off because it's always been a very regional affair. The UK was doing what the UK was doing, the Germans were doing what the Germans were doing, the French did what the French did. So in Europe, we are like, you drive 200 kilometers, different country, in a different cultural environment. So everybody's trying to keep his norms, his regulations, his standards. It's a pain in the bum. And I understand for someone coming to our region, it says, would we rather go to the US because it's a huge market, it's all one regulation, so it's easier.
Right.
But if you look at, let's say, the technology footprint in Europe, I think it's very tempting and still worth considering to go to Europe. The European Machine Vision Association made the difference. It was perceived at the beginning as like a competition to the German Machine Vision Association, but they suddenly learned that the structure of the companies within Europe is very much alike. Average size, 25 to 35 people, university background, everybody found it difficult to source hardware, choose the right software for its algorithms and stuff like that. So as soon as Europe created the European Machine Vision Association with a few smaller companies, and I don't know if you've got anything like that in India. Is there an Indian Machine Vision Association?
No, not that I'm aware of. Yeah.
There are so many clever people here in India. You have a huge output of really people with the right spirit. I mean, when I started 30 years ago, I wanted to be an engineer because I wanted to see the world. And the kind of spirit that I had back then, and that it is hard to find at times with youngsters in Europe, is something I see what's happening here. You really make a difference in your attitude and the way you are looking at things, analyzing things, the way you really deciphered that whole vision and grasping problem is unique. And I think this is due to the fact that you've been educated to look at things. And that is a value. And if you look at the robot community, we have ROS, the Robot Operating System. 10 years ago, that was like considered from the standard robot manufacturers like the devil in person, because you were sharing knowledge about robots in a community across the globe. Nowadays, you find drivers for any given robot out there in the ROS community. Anybody can build a robot, an AMR, an AGV, like that.
Right.
So, and this is similar to machine vision. Machine vision can be applied anywhere. It is complex, but it's understandable. In the end, it's light.
Right.
It's that simple. It's
So,
photons.
so bringing a standard structure in a way where
Helps.
an association
Yes.
has to come about, and then looking at the problem as a common denominator and then start setting up certain
Simplify the
standards around that.
interfaces, you know? You have an end-of-arm tooling, you have a torque force sensor, you have a vision sensor, you have a robot. They all have actuators and sensors. It's that simple. Standardize the interfaces, you're way faster.
Understood.
I understand people want proprietary interfaces. It means a vendor lock-in, which is great for companies, but in the end, we want solutions to the problems in the industry.
So we kind of come to the end of this panel discussion. It has been very inspiring, and a lot of great thoughts have actually come about.
Thank you very much.
Perspectives actually come about. So thank you so much, being an excellent audience, excellent panelist for us, and then opening up all your perspectives and sharing it with us. In case if there are any questions that anybody from the audience would like to ask, we can just hold for 5 minutes that we can pick any questions that comes from the audience.
I am Rajesh from Analog Devices. One question I wanted to ask is, you mentioned about robot being very hardware heavy, but do you see any trends in the software in robotics applications? Big trends?
I think essentially any algorithms that actually come about, right? When we think about software, right? So we are defining a sequence of approaches to optimize the processing infrastructure that we actually have. The algorithm that I might come up for an FPGA would be very different from the algorithm that I would write for a GPU from what I would write for a CPU, right? So often we believe algorithm has to begin from the hardware, and hardware plays a very significant role in trying to bring that whole output as it is. But on the other hand, and software is the only thing that brings the flexibility or dynamism for the system, right? Physical hardware always remains to be the framework within which it kind of operates and then translates it. So, which means it has to be a balanced play, and yes, the software is an integral part without which we cannot think about how that system can perform the kind of dynamism that is supposed to perform. So that's where my thought is at.
If I can add to that, to what Gokul said, see the robot finally is performing a physical task. So there is it's an electromechanical device
System,
which is programmed to do certain tasks. So at the end of the day, it is a mechanical device, but there is a lot of software enhancements that can happen, that are happening now. As a few things that I mentioned previously: virtual commissioning, robot simulation, offline programming, IoT, so to interact with the systems at the management level. So all those kind of things are being integrated with robots to make them more flexible, more usable, more user-friendly, more maintenance-friendly, and more useful in terms of being reconfigurable when you have quick production batch changes.
Problems. Yeah.
So the software plays a huge role in that.
In fact, to add on to so for everybody's understanding, today a robot doesn't even understand that it's touching its own body. In fact, if you think about all these, we have these two kinds of robots, on-axis robots and off-axis robots. So on-axis is the KUKA kind of robots that you actually see, and off-axis is the UR kind of setups that you actually have. Sometimes they can rotate and then fall on themselves, or they don't even understand that there is an item that has been mounted on top of it. A very simplistic UI for us to define where just like a human being is aware of their position of their whole arm, a simple structure like that doesn't exist today. That can go a long, long way in actually making a lot of our programming much more simpler. From that perspective, to the way even the protocol interfaces that even Sven was actually talking about is very complicated today and very inefficient in the way the robots actually interact with different systems. And we in a certain way also try to talk to the robotics industry to see if we can, when we realize this, if we can actually contribute in terms of software development to it. There is a huge scope. Just like once the processor was created, there was so much of apps that you could actually build on top of it. A robot is also a platform on top of which we could build a lot more of applications out of the software, if that's the nature of question.
That was maybe a follow-up question for Sven is, in this machine vision, and do you see a trend in any particular algorithms?
I think, I mean, what we see here is it's pretty unique because, I mean, stereo vision has been applied for ages, but what Cybernetics Laboratory doing is that you can actually move the eyes like the human being, and you can actually also change your focal length is something that will definitely provide or require algorithms that aren't out there. I mean, what you see, and superficially it can be compared, I mean, this is a pick and place application, most of what we see here. But if you look at the tech startups in the US who provide pick and place solutions, for them it's always about picking something somehow and drop it somewhere somehow. You know, it's not very accurate. It's like, I would consider that throwing something. Here we're talking about a very precise way of manipulating something that can be very delicate. And that's why I mentioned, for example, the environment like laboratories. You know, if you're handling samples, you know, that's a different story than handling, if you're Amazon, yeah, and you're picking something from one bin and put it in another in a package, that's a different task. It still is pick and place, but it requires completely different setups than what Cybernetics Laboratory or CynLr is intending to do. And that's why I think you are so special in what you do.
Thank you so much.
Thank you.
You're welcome.
Hi, my name is Gautam. Just wanted to understand, how do you see the growth of Indian robotic industry in the, say, next 10 years or so?
So I'll just answer that by saying where China was about 15, 20 years ago. So there is a metric, there's a metrics called robot density, the number of robots used per 10,000 workers in the factory. So today India is at 10 robots per 10,000 workers. The most industrialized or the most automated country on an average is, for example,
South Korea.
South Korea, I think, and also
Followed by
Singapore.
Japan.
They were
Singapore.
There are 800 or 810. Okay, okay, you can say South Korea and Singapore are small countries, but then if you look at Germany, I think they're at 400. The US is at about 400. Japan is at about 700. And China, which was at, actually, it saddens me to say this, but China and India were at par about 20 years ago. And today, China is at 300. The latest statistic says it's at 300 robots per 10,000. We are at 10 today. We were on par about 2 or 3 few years ago. Today, we are at 10. But in 20 years, China has gone there. So I don't see a reason why we cannot do that in that time. So there is, when you do that, when we go up to those levels, so there is, you know, we are talking about 30 times, plus the number of new manufacturing that we are going to start doing in terms of energy, clean energy and automobile manufacturing, electronics, all that is coming into India, right, which we were not talking about earlier. So combined with all these, you can see that the Indian robotics industry is poised for exponential growth, I would say. So just to give you another number, I think China is the largest market in total numbers at about 290,000 robots last year.
300, yeah.
We were at about 5,000. So we have we have a huge space to catch up. And I think a lot of companies like CynLr and the whole ecosystem that I saw today with Gati and the other companies here all have massive space to grow.
I think what I would shortly like to add is the number of robots per inhabitant is surely important, but it's important, I think, to differentiate whether you're making these robots yourself or you're implementing the robots. Right. Because for me, the robotic world has sufficient robot manufacturers. There have been so many kinematics developed for every single task, and we ended up with cobots, and cobots were not at the end of the line. So making robots is incredibly energy intensive. Implementing them saves energy. So I would rather focus on what you do, providing robots with intelligence, any kind of perception. That's a huge differentiator. Which machine you use, and I don't want to spoil it for any of the robot makers, but the intelligence comes with the perception. The robot itself should be easy to integrate. It should be a reliable machine. That's all you're asking for, I think.
Absolutely. Thank you so much. And I think that was a great question there about how the cost center can be moved to a profit center. And I think especially in the Indian market where we, the challenge of having people replaced by robots, that's a psychological thing. The cost of people is much lower than having robots, that's another thing. And I think we have many such barriers which are sort of holding us from adopting robots in the shop floors and various places. So as a follow-up question, I'm sorry if anyone else wanted to ask some question, but as a follow-up, what are the challenges that you see that we need to overcome to reach having more robots adopted in our factories?
Yeah, so a lot of questions on robotics. So yeah, let me take that. So yeah, it's a very common perception that India is a population of 1.4 billion. So the labor is not a problem. And then labor is cheap. Yeah, I mean, those things are partially true. But also what we are seeing in the market is a somewhat different scenario. So people, customers that we always meet, I know Mr. Murugapan may also agree with me that getting labor to do repetitive tasks is becoming more of a challenge. People don't want to do that anymore. They don't want to work in an environment where you're constrained, you have to do the same thing, you are exposed to different hazards, you are expected to put your health at risk. So that's not something that people are willing to do anymore. Okay, so there is but at the end of the day, cost is a factor. So like you said, we have to build automation solutions that give an ROI, return on investment. That's absolutely necessary. People are not going to invest just for the sake of it. There has to be return on investment. So we have to build more cost-effective, innovative solutions that can address a lot of the barriers, like you said. So there are all these barriers of cost which are always there. But I'm happy to see that there are a lot of localization attempts to bring down those costs that are happening, innovations that are happening with companies like CynLr, with their vision technologies. So those will surely, increase the adoption of robotics in the industry.
One perspective that I just wanted to add also from this, imagining an infrastructure as a cost center towards an earning center. Let's say if I'm just wearing the hat of someone who's running the business and forgetting what is the tech, what is the medium, what is the basis on which I'm actually running it. But let's say I have to build this business and I have to kind of multiply the value in those cases. When I actually sit and look at it, am I looking at that as a means to earn, or am I looking at a means that would enable me to earn through something else that it produces, right? So if that perspective could be changed, when could that perspective be changed? At one point of time, even data processing used to be thought as a cost center. Today, the moment you kind of universalize that infrastructure, that I could reuse it, when I'm acquiring that infrastructure, I'm not thinking of, hey, can it produce this mobile phone, or can it produce this particular con rod or connecting rod or that particular piece? Hey, I have this infrastructure which can produce this metal outcome. Could I start using this infrastructure for any kind of metal parts that I can actually bring about, right? Only if I am thinking of that investment, let's say a 300 crore line that has gone into making a particular automotive engine component, right? Could it also be reused for every other part, right? And what is the cost of repurposing that, right? Often there is limited because of the effort that goes into it and the variety of material that has to be brought into it. Why is there a variety existing for, or why is there a problem of variety that comes in whenever the part changes? Simply because the way we kind of process that part out of a raw material seems to be very different set of methods. Somehow if we can bring that very similar way of trying to extract that shape or that part out of the raw material using one unique, for example, what 3D printers are being imagined about, right? We are not the tech is very nascent, so it's not very reliable at this end. But there are places where it is making immense strides. The way where we can replace casting and forging, which could be any shape forming that it could actually come about. I think the missing piece when it comes to the manufacturing as a whole segment is, while we have the shape forming machines, CNC machines have to a very large extent have been universalized, and robots have been universalized. Sometimes people buy one robot and then start thinking, what can I use it for some other purposes also. But today the products are a very small portion, and 70% of that would actually go about for customization infrastructure. If we could actually bring them all to be more of standard products and standardized segments, from one station to another station, it's the same machinery that goes. Just like a human being, right? The same guy who actually works from one station to another station. But when it comes to a machine that has to apply to do the same task, they look entirely different, right? And that investment that I done for that part is not reusable in another place. I think if that changes, then people will bother less about the produce, but more about the thing that produces it, and they can start reusing that things. Now I will start thinking that, hey, I have invested and I have such large infrastructure. Why don't I go and monetize that in several other problems that we can solve with this infrastructure, right? So I think that would be a key milestone for it to move from a cost center to a earning center for the case.
My name is Ravi Kashi, and I'm from the automotive industry. And I'm kind of curious to understand, how are you kind of creating a component structure like an AutoSAR component? I mean, that's a reusable component. So you could pick up a component from Active, and you can pick up a component from maybe Bosch and put them together and create a product of your own. This could be a software component, or it could be even hardware. So most of these automotive OEMs, they are picking up hardware. They are saying, okay, you build the hardware for me. I will pick up the software component from somebody, integrate them, and I will write the application on top of it for my application of my intended use. So is that something that you guys are thinking about? Meaning your stereophonic vision could be a component for my robot. It's a component that I would add on to my application, right, and then I would have a gripper or whatever else that I want. Right. And it should be modular enough for me to have a standardized interface that application programming becomes fairly simple and straightforward. Or on the software parlance, think of it like an Android operating system that could make so many apps possible, right?
Right, okay. I'm assuming I got the question, so...
yeah, so that's the question. Is there any effort that you guys collectively or individually doing that kind of enables, maybe, let's say you are a vision expert, but there is somebody who is much better in gripping.
Right.
And I want the best of both worlds for my application. Can you create a standardized interface is the question.
Absolutely. So the first point that I want to bring about is no one tech could be completely built out of one organization is what my belief is. Even for us, we have to borrow, we have built the camera entirely by ourselves, but we also have borrowed so much tech from outside to even make this work and start building on top of it. So it's always a combination of things that comes about. If you think about a laptop for that case, is in fact, you spoke about Android also from the perspective. It's combination of if the capacitive screen didn't happen, the phenomenon of iTunes and iPhones wouldn't have actually come about, right? So often if you are trying to universalize a particular problem, we start thinking about the focus that we want to keep is object computers. That's what we internally keep articulating, that we don't want to keep saying that it's an automation system or these things, that our focus has to be trying to make it as standardized as possible to an extent where we are audacious to call that it is an object computer, right? Often we need two hands to clap, and if we need to put together several technologies together to make it universal enough that each customer needs a unique kind of utility out of that, which they would, one person want to use the robotic arm 90% for their problem, whereas vision adds only a 10% efficiency in those cases on solving the problem. Another person might need 70% of vision as an efficacy and 30% of something and something else. You need to have that holistic infrastructure, right? We are we are striving to build that, and we are trying to see how much that we can borrow from outside, and depends upon. So one other point that, again, like for the machine vision that he said, there has to be a standardization that has to come. In fact, machine vision as a field took off after the Gen A cam protocol kind of came about. Till then, each camera is so different, and so for a customer, it's a nightmare to put all of these things together. We want to work towards it, but our first goal is to get this platform towards it. So if this becomes a bottom line, our next step definitely is towards that, and we want to step towards it. That's our focus. So yeah.
So thank you for the interesting insight. And to jump on what you were saying, standardization is key for adoption. And this work in the robotic industry that comes at an international level, how can we ensure that we walk the talk and work globally at the same speed in the robotic and automotive industries? Thank you.
Right. It came about, Sir was also saying sometime before this session when we actually began this, that standardization is the key for mobilizing a tech and then make the adoption happen through it. A global tech needs, if you're building for a global problem, and it's a global solution that you're building, we have to work with a lot of global tech to come together in a certain way. The structures and things that can come about for how we can interface with different technologies and things is a lot more of a business problem today, and how they see their market. The only way by which we can mobilize this is not about CynLr being this or CynLr doing this or what. The way, when collaborative robots happened, UR happened, everybody kind of laughed at it during 2000s when they were trying to build out of an university, if I'm right? What they sold is that they didn't say that, hey, I have a very unique machine, I have this robot that you can work with, and none of that. They said collaborative robots. They started selling the concept of, imagine if you could have a robot that can work along with human beings, right? That became the sensation, right? And when somebody has to go and find about it, it became, UR is the only one who actually had that and so at that point of time, so it happened. But the thought process that a bigger problem, that the industry gets united when they see a larger opportunity and they have to see a larger perspective. So only then they start coming about it. The kind of mobilization happened when Industry 4.0 was brought about. Industrial IoT was brought about. The big data was actually tried to be brought about. When the opportunities were very big, everybody were competing. A lot of mergers were actually happening. A lot of technology associations were happening. Unless and until the problem is articulated really well and the potential of the problem is articulated really well, I don't think this would actually happen. But the first task for us also is to bring that articulation to the world, and then make them realize that working towards this as a focus would actually bring them all, benefit them all in a much more larger folds of return. So I think that might be the key for us to get into that.
Thank you, Gokul.
Thank you so much for being a very patient audience with us. Thanks a lot. Thank you so much.